All right, let's talk about the tech that's behind pretty much every AI tool you hear about these days. Large language models. LLMs. We're going to pull back the curtain and see what's really going on inside these things.
So, have you ever just been blown away by an AI chatbot? You ask it to write a poem about your dog or maybe help you figure out some tricky code, and it just does it? Well, that's not magic, it's an LLM, and it all comes down to a really fascinating game of prediction. So, let's kick things off with a big question. When we say large language model, what are we actually talking about?
Okay, at its heart, an LLM is a type of AI that has been fed just an unbelievable amount of text. Think books, articles, websites, basically a huge chunk of the internet. And all that training gives it one main superpower, the ability to predict what word comes next in a sentence, which lets it create text that sounds shockingly human. Honestly, this is the best way to think about it. You know when your phone tries to finish your sentences for you? Well, imagine that, but instead of just being trained on your texts, it's been trained on trillions of words. It gets context, it gets style. It's a prediction engine like nothing we've ever seen before. Now, here's something that's really, really important to get. These models don't think or understand the way a person does. Not at all. Their entire world is built on math and probability. So let's see how that works. First things first, LLMs don't even see words like we do. They see things called tokens. A token might be a whole word like happy, or just a part of a word, like re or ing, or even just a comma. It's how they chop up language into little pieces they can work with. Right, so a word like restarted, to the model, that's not one thing. It's probably 3 separate tokens, re, start, and ed. And doing this is super clever because it helps the model figure out the building blocks of language so it can handle really complex words or even words it's never seen before. And this is the whole game right here. Once everything is broken down to tokens, the LLM has one job and one job only, to look at the sequence of tokens it has so far and ask, what's the most statistically likely token to come next? And then it just does that over and over and over again to build out sentences, paragraphs, you name it. So check this out. This visualizes that whole prediction process perfectly. If you type in the capital of France is, the model doesn't know the answer. What it does is run the numbers on every token it knows. And based on all that data it was trained on, the token for Paris just happens to have a 96% probability of being the right next one. It's not knowledge, it's just really, really good statistics. Okay, so we've got the token by token prediction down. But how does that turn a simple prompt from you into a full coherent answer from the AI? Well, it's all about a super fast repeating cycle. It's really just a simple 3-step loop. Step 1, your prompt gets turned into tokens. Step 2, the model predicts the single most likely next token. And step 3, it tacks that new token onto the end of the sequence and goes right back to step 2. It just keeps predicting the next token, and the next, and the next, building the response one piece at a time. But here's the thing, not all LLMs are the same. They can be built and trained for totally different jobs, which is what makes them so incredibly useful. Let's look at a few of the main flavors and where you actually see them out in the wild. This table breaks it down really nicely. You've got your casual models like GPT. Their job is to predict what comes next, so they're perfect for chatbots and writing. Then you have masked models like BERT. They're awesome at filling in the blanks in a sentence, which makes them great for understanding the real meaning of text. And finally, you have encoder-decoder models like T5, which are specialists at turning one thing into another. Think translation or summarizing a long article. And because of these different types, you see LLMs popping up everywhere. They're the chatbots you talk to for customer service. They're being used as personal tutors. They're even helping doctors by summarizing complicated medical records in seconds. And of course, they're writing code and creating marketing copy. The list just keeps growing. Okay, this tech is amazing, no doubt. But it is so important that we talk about its limits. LLMs are not magical know-it-all machines, and if you don't understand their flaws, you can get into trouble. For starters, LLMs can hallucinate, which is a fancy way of saying they just make stuff up and state it as fact. They also don't know anything about events that happened after their training data was collected. And just to top it off, running these massive models takes an incredible amount of computer power and energy. And this right here is a perfect example of what can go wrong. Look at this. You ask the model who won an event that hasn't happened yet, or at least happened after its knowledge cut off. It doesn't know.
but its job is to give you a plausible sounding answer. So it just invents one. It gives you a very confident, very detailed, and completely false response. This is a hallucination in action.
And so that really brings us to the most important takeaway. These models are unbelievably powerful predictors. They are amazing tools for creativity and getting things done, but they are not truth tellers. They're just reflecting the patterns they saw in their training data, biases and all. And the biggest challenge for us as users is figuring out how to use their incredible predictive power while never forgetting to think critically about what they're telling us. So how do we navigate that difference? That's the question we all need to be asking ourselves.